Ever wonder what an AI sees when it looks at a picture? Researchers are peeling back the layers of machine learning models to uncover how they process visual data, and the results are nothing short of mind-bending. Let's dive into the science behind these revelations. Imagine teaching a computer to recognize a cat, a car, or even a medical scan. But here's the twist. Instead of just showing it examples, scientists are using tools like rapid serial visual presentation, RSVP, to map the thought process of these models. These visualizations aren't just abstract noise, they're windows into how AI interprets the world. Here's where it gets fascinating. When models are trained on standard datasets, their internal representations look like random patterns. But when they're trained on robust models, systems engineered to resist adversarial attacks, those visualizations start to resemble real-world objects. Think of it like a toddler learning to recognize faces, initially messy, but gradually sharpening into clarity. But there's a trade-off. Robust models excel at resisting attacks, but they struggle to adapt to new tasks. It's like a chef who's mastered one recipe but can't improvise. That's where prompt boundary loosening, PBL, steps in. PBL gives models a more flexible framework, letting them play with interpretations rather than rigidly following rules. The result? Visualizations that are not just clearer but human-like, with textures, lighting, and even emotional nuance. So how do these models see when they're uncertain? Researchers tested AI on 8 datasets, from satellite imagery to traffic signs, using techniques like RLM and ILM. They also tweaked a temperature parameter, a confidence dial. Higher temperatures make models less certain, while lower temperatures force rigid predictions. What did they find? At higher temperatures, RSVP visualizations darkened and flattened, losing intricate details. On datasets like DTD, textures, or SVHN, house numbers, patterns dissolved into uniformity. It's as if the AI simplifies its internal vision, when unsure, focusing on core features while discarding noise. Why does this matter? AI powers everything from self-driving cars to medical diagnostics. Understanding how models balance confidence and clarity could make them more reliable. It's not just about pretty pictures, it's about decoding how AI navigates uncertainty in the real world. Next time you see an AI-generated image, ask, what's the model really seeing? The answer might lie in its temperature settings, its training, and the hidden layers of its mind. Want more deep dives into AI's hidden layers? Hit subscribe and let me know what you'd like to explore next.